So thank you so much, Michael. And now we'd like to welcome Chris to the virtual event stage.
All right, cool. Let me go ahead and share my screen. Marvelous. Okay, so I hope everyone's having a nice day. I'm going to be talking today about some of the reasons why you might like to template Nomad jobs and some of the tools and technologies that are out there for doing that. And I'm specifically today going to be focusing on Nomad's HCL2 support, as well as a third-party tool called Levant. So again, my name is Chris Baker. I'm the lead for the Nomad ecosystem team. So templating Nomad jobs. The first question is why? A number of you are probably already templating Nomad jobs, and you know the answer to this question. The rest of you, let's go over a couple of reasons, and maybe you'll discover that templating is something that you might want to consider doing. The first reason is that while we aspire to make Nomad and using Nomad as joyful an experience as possible, the fact of the matter is that writing job specs is not always the most fun thing to do, especially if you consider all of the stuff that you need to put inside of a job spec for a large, non-trivial production app. If you've watched Michael's talk on how to write a Nomad job, you've seen that there's a lot of stuff that goes into a real non-trivial application, console service, pre-init steps, that sort of stuff. So templating is going to allow you to remove some of the boilerplate in some circumstances, remove some of the fatigue from writing jobs. If you're considering the experience of editing jobs to change stuff, to change job parameters that an operator might do, templating is going to give some ability to reduce those mistakes. And the other one is just reducing the redundancy. If you have a large number of Nomad jobs of different types that are running across a number of different Nomad clusters, if you have a significant Nomad setup, you almost certainly have a fair bit of redundancy across those. And templating is one of the tools that's going to allow you to reduce some of their redundancy. So who's going to use templating then? Operators are going to use it if they're doing manual deployments of batch jobs, or if they're making manual changes to a particular type of maintenance jobs, or if they're even just doing deployments of prod manually. That's one. Custom control planes. We have a number of users who have service catalogs, internal service catalogs that we use inside of their organization for doing deployments of workloads to Nomad. But in these scenarios, the users don't actually write the Nomad jobs. The users, maybe pick from a service catalog what they want to do. They put some parameters in, and then that actually ends up resulting in the Nomad job. So they have a templating engine or a generation engine that's going to do that. And then probably the most popular scenario for templating is in continuous integration, continuous deployment pipelines. I have a job that's running on my Nomad cluster already. Some changes are going to come into my application code base. It's going to build a new image, a new Docker image, a new binary, and I need to get that deployed. There's very few things that are going to change from step to step, but I need to update my Nomad job. And the Nomad job itself may also be checked into the repository, right? I may want my Nomad job spec to live next to the application code, but I'm not changing that job spec every time I'm pushing. That's not something that's done by the CI/CD pipeline. So we'll look at some examples, a number of examples actually for doing templating inside of CD pipelines to show that. So I've used the word templating. This one of my coworkers mentioned this the other day. They didn't like the word templating; they liked the word generation. But the fact of the matter is that depending on whether you want to use templating or generation, what do we mean by templating, and how can we actually do that? And the way that we'll do that is pretty much anything that takes some number of parameters, some input, and generates a job specification, either in HCL or in JSON. And specifically today, we'll be focusing on Levant and Nomad's native HCL2, but there are a number of different tools out there for doing this, a number of different methods for templating HCL or JSON. And I'll mention some of those later. So a couple of examples real quick, a couple of goals. First one's job parameterization. So I've got this idea of I have a Nomad job, but there's a certain number of parameters that indicate how this job is going to be run. These are parameters that I know at deploy time. I don't want to bake those into my job, right? This is inside of a CD pipeline. There's an example here in HCL where I've got a job. It's a web server, right? And I don't want to actually hard code the image, the Docker image that's run here. So what I'm going to do is I'm going to go ahead and list this using HCL2 syntax, say that there is a variable for this job, for this template that we're going to use here. And when it's time to actually run the job in my CD pipeline, I'm going to specify at runtime what that variable is. What is the image that I want to run? And here I just specify the image, but typically it's going to be whatever version of the image, the latest version of the image that I want to deploy, right? Levant allows a similar sort of thing. Here I've got a job. It's got, in this case, an artifact that I'm going to download from the web, a binary from my application. And then I'm going to run that. And then when it's time to actually deploy this, I'm going to specify, using a similar syntax, what the URL for this artifact is, right? So this is what your typical deployment is going to look like inside of a CD pipeline, right? I just need to update the Nomad job that I'm running. I need to fill out this template with the information that I know at runtime, which is, what image do I want to deploy? What artifact do I want to download? Another one is improved readability. If you've seen Schmeichel's talk about how to deploy a Nomad job, one of the things that's really nice to do inside Nomad is to specify an inline template, either some configuration for a job or maybe even a script that you're going to run. So the problem with doing that is if it's, for non-trivial configuration scripts, especially something like an Nginx configuration, these get really, really big. And you don't necessarily want to see them in your Nomad job. It makes it hard to move around, makes it hard to see other stuff. It's not necessary to do that with templating. So both Levant and HCL2 have the capability to take a file that exists locally when you're doing the templating, when you're running Nomad. You take that file and pull it in and put it in the appropriate place in the job spec for deployment. So in this case, an Nginx configuration, or in the case of Levant, same thing here. And then modularity. Modularity is our goal here is to recognize there are certain structures that are going to show up in our code. Certain structures are going to show up in our Nomad jobs over and over again. And we don't want to have to repeat ourselves. We want to be able to pull these out, certain patterns. So one example of this is maybe I have a list of sidecars that I want to run. And if you look inside, they all sort of have a similar shape. I have a task, it has the Docker driver, I specify the config, blah, 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 blah. If I'm doing this linearly in line without the use of templating, I'm going to have to repeat this over and over and over and over again. And I may find that there actually is a procedural way to do this that doesn't require me to repeat myself so much, right? We don't do this when we're writing code normally. We have for loops that we use in most of our languages. Templating is going to give us a similar sort of capability. Dynamic task blocks. Dynamic blocks in HCL2 give us this ability. And there's similar structures in Levant for doing this as well. So just a quick refresher, this is actually pretty important here on the Nomad job spec. I've been talking about HCL and I mentioned earlier JSON. And I said you could do templating in either way. What does that mean? Well, when we write Nomad jobs, a lot of the time we're going to write them using HCL. And the reason is the HCL is, I feel, and I imagine most people feel who are here anyway, the HCL is a lot friendlier to write than JSON. It's going to give us the ability to do things that in JSON would be very verbose, very wordy, very syntax heavy, very repetitive, right? So Nomad's job specs typically are written using HCL. But the Nomad API is entirely JSON oriented, right? So where did the JSON come from if I didn't write it? Well, that happens inside of the Nomad CLI. When you actually run Nomad job run, what it actually does is it parses that JSON. It parses it into a Nomad API job object, right? Using the Nomad SDK. And then it turns that into JSON and it sends it off to the server using the job register endpoint. We actually have an endpoint which will do this as well if you don't want to use the Nomad CLI. It's v1 jobs parsed, and you send it the HCL, and the server will parse the HCL and then return to you the JSON that the CLI would have done. You can then turn around and round trip that back to the server if you like. It's nice if you want to have your own JSON representation of your job instead of getting it back from the server. So, so there are a couple of different options then for templating. You can write the template into HCL. You can template into JSON. And you can use pretty much any tool you like that will generate HCL or JSON. So you can use, the Nomad SDK is a popular way to do it. We provide a Go SDK. We provide a Java SDK if you wanted to use that one. You can write code. You can use any other tool, though, that's going to generate valid HCL or JSON using any string templating library that you like. So I'm going to be focusing, though, just today on HCL2, the Nomad's native support for HCL2, as well as Levant. So our native support for HCL2 came in Nomad 1.1. Previously, we supported HCL, the original version of HCL. But HCL2 actually builds a lot of new capabilities that are very nice to use. And among those are the ability to parameterize using information that's known at job submit time, at templating time, at a job registration time. And this is information like environment variables. You can put environment variables that will indicate the variables that will go into the HCL2 templating. You can look at the local file system. For example, the example earlier that pulled in the Nginx configuration and put it into the Nomad file for use in the Nginx task. That was an example pulling from the local file system. So some other file sitting inside of my repo. And then also command line variables. I can do -var to specify these variables, or a whole file which actually contains a large number of variables. This is very useful, for example, if I have one Nomad job that I use in both production and test, for example, but I have a different set of variables that I want to use between them. I can put those variables into a file, prod.env, test.env, and then just when it's time to do deployment, use the appropriate variable file for that environment. So there's a lot of different features that are going to come with HCL2. The input variables, local variables inside of the template that you can compute using the different expressions, a standard function library. There's conditionals, there's dynamic blocks like I showed earlier, and I'll give another example later. And then operations on collections, maps, sets, lists, and then just general basic string templating as well. So if you look at the documentation for the job specification, we have a whole section on what's possible with HCL2. Levant is the other tool that we want to focus today. So Levant is a popular CI/CD templating and deployment tool. It was written by James Rosell, who's a member of the Nomad community, and Levant has been adopted by HashiCorp. James Rosell has also been adopted by HashiCorp, so this is a very good deal for us. Levant is very popular out there. It was designed to be used in CI/CD pipelines, and therefore it actually captures two real main capabilities. The first one is making sure that your jobs are actually deployed. So if you do a Nomad job run, it runs the job and maybe the CI hangs around, the CLI hangs around and makes sure that your allocations are placed. Levant deploy actually does a fair bit more. It will actually make sure that your app is successfully deployed and healthy before it returns. This is the sort of stuff you want to know when you're running your CD pipeline, that it actually did run and is up and healthy. Otherwise, you need to turn something red in a dashboard somewhere. But the other part is templating, right? And that's the subject of today's talk. The difference between Levant and Nomad's HCL templating is Levant is actually a generic string templating language. So all of the templating that Levant does is just to generate a string, an HCL string, hopefully valid HCL, and then it actually performs HCL parsing. As a result of that, it actually performs two phases of templating. You can do your Levant templating to generate HCL, and then it'll parse the HCL, which also might have some templating in it. This is really interesting because it lets you do a couple of things that aren't necessarily possible with HCL2 today by itself. So you should consider that if you're running into something that you can't do with HCL2, it may be the case that Levant is going to be the answer for you. So you don't have to write your own templating language. It also has some nice features like rendering console configuration at render time. You can pull from console to put something into your Nomad job. And then you can also just render the HCL. You can run the Levant render command, which will give you the HCL that it would have used. And then it has access to its own function library using the Sprig standard function library. So check out the Levant project for documentation there. We also have some wonderful tutorials up on our website and on the Learn website for doing templating with Levant. So let's look at a couple of examples. Oh, I'm sorry. Which tool? Which tool do you use, right? HCL2 or Levant? The standard advice is you should use whichever tool works best for you. If the tool you're using isn't working, you probably know about it and you probably know which one you need to use. So in general, I can't really tell you which one to use. There are a couple of generic pros and cons. The first one is that there is first-class support in Nomad for HCL2. So you don't need Levant. If you don't need Levant, HCL2 is going to get you everything you need without having to install Levant, right? In fact, you don't even have to install the Nomad CLI. You can take your HCL specification, HCL2, you can send it up the server using the parse endpoint. It'll send you the JSON back. You can turn around and send that back to the server again to register your job, all using curl, right? You don't have to have the Nomad CLI installed. So if that's what you're interested in doing, that's fine. If you're building your own tooling around the Nomad API, that may be what you want to do. However, if you are interested in using some of the capabilities that Levant provides, if you are looking for something that's a little more useful inside of a CI/CD pipeline that doesn't require you writing a lot of scripting around the Nomad API or the CLI. Levant that's what it was designed for. So you may find that it has support for things that you want, including, I'm going to call it out again, the support for pulling configuration from console. So some examples, HCL2 dynamic blocks, I mentioned that earlier. This is actually an example from our documentation. So we have a scenario in Nomad right now with CSI volumes in this job right here. I have a group. I want to run a job. It has a certain number of instances, and each instance needs to be backed by a volume to persist all of the data, right? So in this case, the task is Redis. I'm going to mount into the job this volume, and this volume is provided by CSI. The problem that we have is that these volumes right now, we need a different volume for each task, right? Because these volumes are named objects in Nomad. So if I were writing this job spec in HCL1, I would find that I needed to have a different volume stanza right here with a different source for each one of these tasks. And it's sort of tedious to do this, right? You have to say task, Redis 1, task Redis 2, task Redis 3, or sorry, not even task, group Redis 1, Redis 2, Redis 3. And the only thing that would be different between those three groups is that they had a different name and they referenced a different volume. Everything else in them would be the same. And it's a gigantic redundancy, a gigantic waste of effort. It doesn't look good. It doesn't feel good. So when you have something like that, normally you're going to write a loop to solve this problem. And that's exactly what this is doing right here. It's saying we have a loop. I want to instantiate three different groups. Everything is going to be the same except this one thing right here. I'm going to say, here's how I find the name of the volume. We did it here procedurally generating it using the index, but you could actually, that could be a variable inside of this loop. You could specify the volumes that you want to run. So this is just one of the most wonderful features, in my opinion, of HCL2 is these dynamic blocks. You can have a lot of fun with these. Another one, Levant has a similar sort of capability. Remember, Levant is just doing string templating, So it has support for these loop structures, and you can do that to generate this as well. It looks a little different, so let's go ahead and pick this one apart. I've got a range operation here. This says that I've got, I want to range over some structure here. And in this case, it's a key value of a name for the key, and then actually a file name for this right here. And so what I'm going to do for this one is I'm going to instantiate a new task group for every single one of the bits here in this fragment. And it's going to pull in the constants of this fragment right in here. So whatever I had inside of this group file, this group fragment, it's going to put in there. That's my main task, but maybe it's volumes, maybe it's services, maybe it's networking stanzas, could be anything. But then alongside of it, I'm going to go ahead and inject this right here, another task. It's my corporate sidecar, which does all of the things, all of the policy governance, whatever, all the snooping and enforcement that my corporate overlords want me to put inside of my groups, right? So I can put my group fragments in this file and I can write this, but this is ultimately the job that's going to be run, and it's going to allow us to put these sorts of things in. This capability, I don't think, I haven't figured out a way to do it yet, isn't really possible with HCL2 right now. So this is one of these examples that where Levant's templating actually gives us a little extra capability that we can't do with HCL2. And then another example is, as I've mentioned this multiple times, Levant has the ability to pull from console at job templating time. So I can, inside of my Levant template, I can actually reach out and talk to console. Levant will reach out while it's templating and talk to console. And in this case, look for this key, service, config, file beat. Should I turn on file beat for my jobs, for these jobs? And then it will go ahead and render this brand new task inside of this, right? This is a conditional. It'll put in this task, the sidecar, and it will, this is just another task, sidecar task here. It can even pull additional information from console, right? What is the what are the hosts that I want to pull? This config I pulled from the documentation. This is not a very good example here, but what are the hosts that I want to pull to talk to the Elasticsearch where I'm going to send my logs, right? And you can do any number of different things. You could pull in the image for the sidecar. So there's certain fields in Nomad still that aren't entirely referenceable by templating and conditionals and that sort of stuff. But to be able to pull this from console while we're doing the templating, as opposed to maybe having to do other things at runtime using Nomad's existing template stanza is really, really helpful in some circumstances. It is the solution to the problem in certain circumstances. So this is another one of these examples. If you run into something that you can't figure out how to do with HCL2, reach out to us and talk to us, because it may be that the answer is do it with Levant. So what else is out there? There's a lot of good resources out there for doing templating. Recently, there was a talk that Tracy Jakewith from the Internet Archive did on GitLab and Nomad, a Get Upstream Come True. It's a fabulous talk about how to use Nomad inside of your GitLab CI/CD pipelines. As you might imagine, it uses a ton of templating. It previously, I think, the setup that they had at the Internet Archive for this used Levant, but my understanding is that it's shifted all the way over to HCL2. So go check this talk out. It's a fabulous talk. Much better CI/CD stuff than I'm going to show you here, or am capable of showing you. Another team member on the Nomad team, Chris Hicks, started a project the other week, libsonnet Nomad. So if you're a libsonnet person and that's how you want to do your templating, there's a library out there for this now. So check it out. Contribute, see if this is something you're interested in. And then of course, hit the documentation. If you go to the job specification documentation, we have a whole section on HCL2, and we have a number of